Hey guys, it's Vince. Today with Mastering the Method, we are going to be covering my Method X from Makerbot. Many of you already have either the Method or the Method X. And you've probably seen the video where they discuss a very ambiguous method of cleaning the extruder nozzle. Now, you can see that this nozzle right now, this is the experimental extruder, Gen 2 model. You can see I have some nylon carbon fiber string hanging out of it. And this filament is going to naturally do this whenever a print is completed. So what you're going to want to do to clean this in what I feel is the optimal method and the only method to clean this so that you get accuracy when you do an assisted leveling, which will follow this, is you're going to come up here to, again, the screen. You're going to click on Advanced. You're going to click on Clean Extruders. Now, when you set up Clean Extruders, it's going to ask you to enter in the custom temperature. You can select a pre-selected temperature. I don't like to do that, and the main reason I don't like to do that, and they don't discuss this, is the higher the temperature you use, the more ooze you're going to get from the filament from back pressure within the extruder. Now, how do I know this? Well, now printing at over 200 hours on this printer, I can tell you I've seen just about everything it will do. And my recommendation is you can try it either way, but if you click on Enter Custom Temperature, when I clean with nylon carbon fiber, I like to leave the set cleaning temperature at 230. I still get some ooze, but it's much less than if you go higher and higher. The other thing to keep in mind is you just want this temperature to be hot enough that we can make sure that our extruder nozzle is clean. Now, before I go through with the cleaning process, tools that I recommend. Again, Makerbot doesn't recommend much of anything, and this is where they dropped the ball on this printer, I feel. This is a dental mirror. Now, why do I use a dental mirror? Because when I come in here, I can now see what my nozzle looks like on either end. I can see if everything is clean. I don't care what 3D printer you're using, this is a great tool to have. The other thing I use is their stock brush. This brush is okay. It's nowhere near as effective as using a micronized Dremel tool or rotary tool, and then I use a stainless brush in just a centrifugal pattern. This is just a round pattern. So when this spins, it's going to clean the nozzle and also remove any debris that's melted from the filament on the end of the nozzle. Okay, it's very, very simple to do. I can set my RPM. This is 5,000 with one LED lit, 10,000 and 15. I never recommend going past 10. Because these brushes flare out from centrifugal force, and you can see that. So then we'll come up here and we'll clean that. You also want a good pair of flush cutters, okay? And I'll show you why. So now that we've got our tools all set, everything here makes sense, we're going to hit set cleaning temperature and just let her heat up, and you can see your nozzles now are heating up. Once we get near 200, you might even see some ooze start to happen. Usually it doesn't happen on mine until about 220-ish, and you'll start seeing that string get slightly longer. Temperature's climbing rapidly. Now we're breaking 200. And you'll find that this gets very, very, very hard to break when it's cool. As it gets heated, it becomes much easier. You can even hear you're getting slight extruder back pressure, and this should pop right off, and it did. And now if we watch, and she watches closely, you'll see slight ooze coming out. Okay? Now, of course, Makerbot didn't cover this. I don't know why. They like to cover a lot of different things, and I think they should really focus on more of the detailed points of this printer, because it is not being discussed nearly enough, I feel. And after doing many prints with it, we can see this ooze keep coming. I'm just going to pluck it. Very simple. We just keep letting it come. Now your temperature is dropping, even though it says that this process is continuing. And you're not seeing a temperature here, it is dropping. And how do I know that? If I click right on that back arrow, and I click Stop Process, you're going to see Now it says clean extruders again. I'm going to go back, and I'm going to go back, and I'm going to go to material. And the reason I am is because I can see the temperature of the nozzle, and it's dropping. So right now, you can see that ooze is stopped, and now I'm just going to clip it. And this is why I'm using my Nipix, which are flush cutters. Now I'm going to come in here with this nozzle still warm, and I'm going to go up to 10,000, and I'm just going to gradually touch this. And what I'm doing is basically sanding very mildly with the mild abrasive of the stainless brush the tip of the nozzle. Now you don't have to worry about anything because these nozzles are hardened stainless. And the thing is, you want to come around here real gentle. I'm not putting any real pressure here. You don't want to put any real pressure, just let the tool do the work. You can see why I use a cordless one, because a corded one would not fit within here. But by doing this, you are assured that when you do a bed leveling sequence, the nozzle is going to make proper contact with the print bed without having any excess filament on here. Done. That's it. That's the whole process. Now to double check my work, what I do is I put the mirror to it, and you can see an immaculate nozzle. Now you will have heat patina, which comes just from the nozzle getting to the temperature it does. I do recommend polishing the nozzles, and I'll cover that in another video, and that's how you keep them in impeccable shape. Now, we know we have a clean nozzle. We know that the temperature is still cooling, because if we look here, we can see our temp, and it's going down. So we'll back out. Now what I want to make you very aware of always, and this is something never discussed, and I don't know why, and a lot of people are wondering why this printer costs what it does. If you come under advanced, when we come under sensor info, this is where things get interesting and separate this printer from many others. You can see in each bay you have a hygrometer. It's reading the humidity. Now you can see my bay 2, I don't use my PVA much, and I'll discuss that in another video. And you can see how high it is. It's at 22%, which is ridiculous. You can see in filament bay 1, where I've got my nylon carbon fiber, I'm at a humidity level of 13%. Now I'm going to tell you guys a secret that many of you may not know. This printer, what makes it so unique is that with this hygrometer, all you're looking to do is keep this at about 10 to maybe 11% humidity, and you are going to have virtually perfect prints. That will remove basically all of the humidity from the filament. Now what usually happens is you purchase a new roll of filament. I've done it many times from Makerbot, and they don't really disclose much on it. They say load it and you're good to go. That's not the case. You want to follow a drying process. Now I have a Filament Dryer Pro here I modified. I will cover that in another video. I also have my Fluke 179 True RMS multimeter because I don't screw around when it comes to measurements. And when I want to take a heat measurement, I've got my temperature probe set in there, and I can take a heat measurement. Okay, I can also cycle between Celsius and Fahrenheit. So I know these numbers are dead nuts on. But what gets really interesting is many of you also don't know this has a drying function within the printer. We're going to cover that in another video too. But right now, I want to make you well aware of the humidity in bay 1. If you see your humidity going much higher than 13%, where I am now, I would say between 14 and 15, it's time to run a drying cycle for your material. Printer has settings for that. We'll cover that in another video, but I wanted to make you aware of these settings. You also have other settings here. Your motion status, very interesting to see exact positioning of where your axes are. Your tool head calibration offsets, you have those also present. Okay, as we come down, something else to point out, and a lot of people don't even realize this, we're going to come way down. You can see your chamber, sensor temp, door closed, camera state, coming down. You got a lot of great information here, and this is something very, very, very important. Encoder ticks for your axis. So it's registering where your actual axis is. Very important information so that you don't lose position. A lot of people don't know this printer has that. These are features Makerbot should be making known and are not. Again, you can see your current temp on each nozzle, and you can see B2, A1, those are your actual tool heads. So again, guys, we have some really interesting information. And now that we've got this information all set, I want you guys to do one other thing as you're doing this. Get yourself a pad, a legal pad, a pen, And you have this here so you can take notes on these videos so you can implement the process that I'm showing you. So now that we've already got this already set up, nozzle's clean, and now it's cooled down. It sounded like I was wasting time. I'm not. I was talking and showing you this information so that the nozzle will be cool. Now we're at 78 degrees Celsius. We're still not cool enough. The next step, and I don't care if you just bought your printer, do not take for granted that you're going to use any 3D printer or robot out of the box. It is not possible. What you want to do, because you of course don't know how this unit was handled in shipping, you want to click on Advanced after we make sure your nozzle's clean if you've already used your printer, and if you haven't used your printer because it's new, you will not need to do that, of course, because your nozzle will be clean already. You're going to come in here, and you're going to first remove your build plate carefully. Carefully. I see guys manhandling their build plates. You don't need to do that, okay? We're going to remove our build plate. If you have a clean base plate, you're set. If you don't, you also want a quality microfiber towel. Why? So you can come in here after every time you use your system and properly wipe down the base plate. Now, why do we do that? Well, I'm going to tell you why I do it. This is $6 grand. Okay, do I need to tell you that this is expensive? No, you guys already know that. This is not a toy. This is not a Prusa that's, $800. This is a true commercial grade 3D printer. It's just smaller format. So let's treat it as such, and it'll last as such. Now that that's been done, we're going to come over here and click on Assisted Leveling. Now it's going to say Build Platform Leveling. Assisted Leveling will check out your build platform and prompt you to make any adjustments. You're going to click on Start Leveling. Now once we do that, it's going to drop the build plate. Watch. Now it just did that. Now it's checking levelness. Open door, remove build plate. We've already done it. The extruders need to hit precise points under the build plate. Now if you look carefully, here and over here, all these areas that you see paint missing, it's because this process has been run so many times, as it should be for calibration. So now what we're going to do is I'm going to say next, because the extruders need to hit those precise marks, and again the build plate's been removed. We'll click on next. Very simple. Now, Makerbot's video covers this, but they don't discuss why you need to do this on a new printer. And you can see now our nozzles are cooling. You know why? Because the printer is detecting they're too hot to make safe contact at this temperature with the actual build plate. And when I say that, that's the actual build platform. The build plate's been removed. Makerbot wants people to believe that even though they've shipped this printer thousands of miles in a really great packaging box, that this unit is ready to print out of the box. It is not. The unit's still made in China, and China believes in quantity output before quality in the sense of doing meticulous details for setup. And as an engineer, I know that none of them are doing calibration because mine was completely off from the factory. And when I first got in the system, I'm wondering, why am I having problems? Well, I knew right away that the calibration was built into the system, and as soon as we went through and performed the assisted leveling calibration, printing changed virtually immediately. So I'm telling you guys, do this from the get-go. You can see our temperatures are dropping once they hit 50 degrees Celsius, or in which case your printer is new, you wouldn't have to worry about that, and it would go right into the next portion of this video. Now this video is of course long, but there's a reason, because we're covering it in great detail, in which the manufacturer, I wish, would have done. A couple minutes later, you'll see that this will just speed down. We're almost there, guys. Just bear with me. I recommend definitely getting your build plate ready, which is something we will do. Now you see the elevation starting because the temperature dropped. Smooth contact being made with the base plate, so calibration is being performed. It's taking its measurements. Okay. Insert build plate and close door to finish leveling. Please insert the build plate back into the printer and close the build chamber door. Now, I want to discuss something. Many of you may not get this message. Many of you may get a message showing where to make adjustments if the build plate is out of level. in which case then you will make adjustments, and you will make very, very small, precise adjustments. In my case, I've already leveled the system. Therefore, you're not seeing that. In another video, I may cover that. But I can tell you right now, this system is now ready for insertion of the build plate to do final calibration. Before we do that, though, I'm going to cut the video. I'm going to apply glue stick to the build plate so you can see that process, and then we'll go from there, because we want the build plate to be set up in a fashion that is exact for printing. Okay, if it's not being set up in a fashion that's exact for printing, you are going to throw off the tolerances of the build plate from this measurement, because any additives that you add to the build plate to increase adhesive strength for your prints, it's going to throw that tolerance off. So we want it to be exact as if you're ready to print. Stay tuned. Okay guys, I've got the build plate removed. I've got my large microfiber so I can set this under the build plate. Again, I like to protect my stuff. It's up to you. It's your printer. Applying glue stick, not rocket science. We apply a nice layer. Done. And over here, done. Now, before you do this, I didn't think I'd have to mention this, but I'm going to mention it because every video does mention it. You should be cleaning your build plate with what I recommend, Dawn dishwashing liquid, because again, it's going to degrease the build plate. I then blow mine off with an air compressor. Why? Because I don't want any remnants of water or moisture on this build plate. Now, some guys go, well, Jesus, that's an expensive investment. And I say you just dropped $6,000 on a printer that's supposed to be commercial grade. So the investment you're making on the robot should also follow suit with the equipment you have in your shop to support it. That's my logic as an engineer. Everyone's different. Now that we've got our glue stick applied, here's something you don't usually see. Let's say you put a lot of glue stick on, okay? Now we know you are never going to get this glue stick completely level on your build plate. Now, I recommend a 3M squeegee. Why? Because now I go over this lightly, and you can see what it's done. It's just removed the texture, and I go also the other way. This makes sure that you're really smearing that glue stick into the texture of the build plate and also flattening it. We want a nice squeegeed area. Now that's my preference. It may not be yours, but I'm going to tell you this. There is no way in hell you're getting an absolute perfect layer of glue stick. What you're doing is just building up in different areas because our hands are not level in that process. When you do it this way, it works at a much better rate. You need much less glue stick and you get a perfectly level build platform. Now, once we do our Z calibration, it'll make contact with the build plate, and we know we've set this unit up in the same manner that it's ready to be printed with. She's going to cut this, and we'll go back to the printer. Okay, guys, we're back at the printer. I've got the build plate all prepped. We're going to open the door. We're going to insert it carefully. You want to handle this gently because we don't want to throw off the calibration on our Z-axis, meaning our build plate. You can see how the magnets just kind of grab. We're all set. We've got our glue stick applied properly and spread. Close the door, hit continue. Now it says sensors indicate the build platform is level, which is great because I've already done the leveling. Begin Z calibration. Now it's going to come over and tell us to remove the build plate once again. Remove the build plate. This part of the process is performed with the build plate removed. Once again, you're going to lift carefully. Let the magnets break carefully. Then you're going to rotate slightly and just add enough pressure to where she pops. There you go. And just lift off. You do not want to manhandle this area because we don't want to throw her off of calibration. Build plate is removed. Like that. Now it's saying check extruder nozzles. Now you guys already went through the cleaning process with me, and that's why we did it so carefully. We don't need to clean our extruders, in which case we hit skip, and you're ready to go. Once again, you can see your temperatures come up, and again, we're under 50 degrees Celsius, so she's going to go right into the actual Z-axis calibration. You can see your speeds are adjusted on your Z-axis accordingly so we don't impact hard into the nozzles. Again, the printer's hardware is amazing in how this is fully integrated in the system. And now it's going to switch nozzles. We're going to do the same thing with this nozzle. Very slowly and carefully. You see there's two speeds of one. The first rotation's a little quicker than the second. Now we're going to insert the build plate and do a calibration to its measurement. Okay? Insert build plate. This part of the process is performed with the build plate installed. Very simple. Grab your build plate. We're going to place it in carefully once again. Come in, let it set. Very gentle. I'm not using any pressure, and just let her fall. There you go. Done. And it just reseats itself. Now, the reason I recommend doing this before you print, on every print, and of course setting up your printer the first time, you never hear them say, do this before you print every print. Do you know why you would do this every print before you print? Because there's no way in hell you're ever going to get that build plate in the exact same spot every single time. I don't care what mold they use. As an engineer, I'm telling you, it's impossible to do. You must do a calibration on your Z so that you make sure that you're getting that measurement from your Z-axis to your base plate every single time to make sure that height is perfectly adjusted. And for how fast it is to do, I don't understand why no one does it. I don't understand why Makerbot's never covered it, but it should be done. Build plate is installed. We'll do the final step in the process. Now, when it makes contact, it's making contact with the glue on the surface as well as the surface itself, just as if it were printing, so you know this is in the exact format it will be printing on. Done. Calibration successful. Everything is set. You are now ready to print. Why? Because that build plate is set in place and measured to that exact position. Now, final step, something never discussed. This is my own recommendation. You do as you'd like. I take the material and I come over and purge just a teeny bit. And again, I set my temperature at 240 degrees Celsius. Now, of course, I'm using the experimental Gen 2 extruder. Therefore, I can put in custom temperatures. I highly recommend just buying that extruder because it eliminates using virtually every other extruder on the market. Right now, I've got it set at 240. I'm going to hit load. As soon as I get some filament coming out, I know that this nozzle is now preloaded. That means that when it goes to initially go to print, it's not going to be struggling to reload and trying to get a perfect bead. It'll already be done. This takes a couple extra seconds, but it makes your prints virtually bulletproof. Trust me. We're just waiting for them to heat up. Almost there. Now, I do not recommend printing this filament at this temperature. This is just enough temperature as far as being high enough to get us to extrude. And there you go. Once it hits the bottom, we hit confirm, done. Now, do not be tempted to pull that piece as it's hot. Wait for the extruder to cool slightly. The reason I say that, you don't want to disturb the way that filament is going to come out of the nozzle for that first initial run. You're better off just letting it cool. You've got your flush cutters here. And what I found out is by letting this cool down to about 200, maybe it's slightly under 200, it becomes just solid enough to where you can snip it. You don't want to pull it, you want to snip it. This way that filament is level with the extruder and you're set for that first run and you should get a perfect first layer, which is so critical. Again, guys, everybody is different in what they intend to use their printer for. This printer I use to print for profit. Therefore, I have to get a process that's bulletproof in terms of consistency. That's why I put these videos in this channel together. This printer is one of the most underrated printers when it's actually being shot down by so many people because they really just don't understand it. Now we're good. We're at about 175. We're going to just take it and just do exactly like I said. Just lay it. Boom. You can see we even got a little piece there. If you get a little piece, just try to come up and clean it carefully. Done. You're all set to print. Now, I'm going to discuss the final step, which is the icing on the cake. Grab your pad, make sure everything else is set. I then come over here usually and select print. I take the top cover off. Something else never discussed. Before every print, make sure your bounding tubes are properly secured inside the nozzles. That doesn't mean you're jamming them in. That means you carefully press them and make sure everything feels tight. This feels tight. Now that this has all been confirmed and checked, let's place our top lid on, and now you've got peace of mind knowing the printer is now set to print. I want you to try this method, and like I said, we're mastering it, so hopefully it will yield much better results for you. More videos are to follow, many more, and just as detailed, so I hope you stay tuned to the end. Please like and subscribe, and definitely I want to hear your comments. I hope you guys have successful printing. Take care. Hey guys, it's Vince with Mastering the Method, and today we are going to be discussing slicers to be used with the Makerbot Method and Method X format printers. Now, keep in mind, and I'm going to state something that many of you already know or have read online, the only issue with this printer, believe it or not, is the slicer that comes bundled with it, or that Makerbot allows you to use. In this case, it's the Cloud Print Slicer. Now, what I'm going to do, and I want you guys to be the judge, and I hope to hear your comments below, is I want you to check out the slicer I'm using, which is Simplify 3D 5.1, which is their latest version, versus this Cloud Print. Now, you can see I've got Cloud Print right here. It's a very no-frills type slicer, but the thing to keep in mind, guys, and again, I'm speaking as an engineer, the hardware that you're working with the robot is pretty much basic. 3D printers have been around forever. I mean, we're really getting into the realm of, 10, 12 years they've been on the market. The method has been really updated in terms of what the hardware that's been currently available on the market can do. But keep in mind, the biggest caveat with any hardware is how well the software is able to support it. And what I mean to say is, if you get a printer, a standard printer, and the driver sucks, you're going to have really horrible output with that printer. And it's no different than with the Method and Method X. Now, let's take a look at the Cloud Print software. And again, we've got this little arrow here, and it's pointing to the left. We're going to click on it, and you can see it actually breaks open all of the settings. And right now I've got the printer type I've got is Method X. Again, I'm actually you can use Method X, whatever. I'm just doing this as a demonstration, and you can see how the settings are set over here. It's very, very basic. First of all, you can't explode this into basically a bigger area. We can't expand it like a typical window in terms of what we're used to with Microsoft. So again, looking at this, and then coming down here and seeing more settings, you can click on printer, and you can see you've got very limited control on purge towers, purge early end, support extruder wipe, which I've used and it really does nothing. Purge tower, the one thing I do like, you'll notice if you drag your mouse over, it does explain the features, but the thing that you're going to find is that you have very limited control using this slicer. The driver, so to speak, that came bundled with this printer is very low quality, and there's no other way to say it than that. It looks like they cut a lot of corners developing this software, and if you look, and in my case I'm using the experimental extruder, and if you guys are using that, you can see I selected extruder here, and you can see all of these settings, and I mean some of them again are going to come with an explanation, and some of them are not. And when you look at this, you have to go through all of these settings to get a decent print, or to manipulate to get a decent print. Now my question to you is, what do you value your time at? Where do you start drawing a line and say, you know what, my time is too valuable to sit here and try to decipher all of these settings? Now I'm going to tell you what I did. When I first seen that this software had proprietary slicing, I realized that being there's no other software on the market you could use with it, this is where most people become most frustrated. Well, there's a light at the end of the tunnel. Needless to say, I didn't see that light because it took me months to actually learn the printer and then figure out that Simplify had come out with supporting the method because they own one themselves. But needless to say, it forced me to adapt and overcome, so to speak, in terms of learning all of these settings. And I went online on Google, and there's a website that you can go to and look up Makerbot definitions if you want to do it. It took me literally months to figure out most of these settings, as it will most of you. Even if you're coming from a 3D printer background where, again, you've worked with many 3D printers, this printer is very, very different in the settings that it offers. It's not very basic. A lot of these settings all have to be manipulated to some degree just to get the printer to function. The other thing that really sucks, in my opinion, is that you can see here, whenever you go to print, it's mandatory for the most part that you use a purge tower. And if you don't use a purge tower, your prints are going to suffer. At least for me, they did. Now, the other thing that I want you to keep in mind is that when you go to print with the method, you typically have to print a PVA RAF mandatorily to actually print a component. Now that means you're wasting that material over and over and over again instead of perhaps just printing on the base plate and seeing if you can get away with that. And I can tell you right now, for most prints you can when you change the software. I was using their cloud print and I was not able to do that. So again, you can see here all of the different settings. I'm just going through them pretty quick, but they are very basic. And again, I hate the fact that this is as big as these settings get, and there's really no other way for you to decipher most of these unless you use the Makerbot definitions, at least for me. And if you are well versed in them, then I guess you're ahead of the learning curve. But for the most part, that's not the case. The other thing you're going to see, and this is odd in my eyes, is that you've got these settings here, and it says quick settings, and then as you come down, you can see it says lab settings. Well, it took me a while to figure out that lab settings was actually allocated to the labs extruder. And these are the additional settings that you can adjust with the labs extruder. And just look at this. Look at how long this is. It is absolutely ridiculous. I'm just going down and going down and going down and going down. I mean, this is absolutely ridiculous, especially considering most of these do not have a direct explanation. And they do not have a direct explanation for the most part within that actual website that covers Makerbot definitions. So you can see, and then it stops, the bar stops, and then it just keeps going. I mean, it's absolutely ridiculous. This just keeps going. There's about, I would say, a couple hundred settings here that you can manipulate. And for most end users, I don't care how in-depth you are with engineering, this is just not practical. Okay, most end users want to hit the ground running, and with a $6,000 printer, for the most part, you would expect that to be the case. So now that you see what you're dealing with here and what you're basically left with, you have a choice of using this software. And once again, most of you are going to experience the two most common complaints online with the method. And usually it's around the slicer, and then the second one being, of course, dealing with ooze, whether you're dealing with nylon carbon fiber or you're dealing with PVA. I can tell you that the first main step to eliminate ooze, and I will cover this in another video separately, but I'm just going to touch base on it, is going to be drying your filament the second you get it in. This is not discussed. I have not really seen it discussed anywhere. I don't care how well packaged the filament is. The thing to keep in mind is filament, you have no idea how long it was sitting outside of its initial packaging when it was actually manufactured. None of us do. So unfortunately, what these manufacturers lack to tell you, or at least the majority of them, is that you should be drying this filament at the immediate time that it's delivered to you so that you know you're starting with a fresh roll. And you should document how long you dried your filament to give you the best results. And why do we document? We document as engineers because we understand that by doing so, we then have a point of reference to refer to, so we gain more intelligence from that data. You don't want to be basically a cat chasing your tail where you just put filament in, you dry it, and then, oh hey, I'm getting great results, and you never document anything. You're never really staying up with the maintenance, so to speak, area of the printer. It plays a crucial role. Now, once again, I said I was going to touch base on that briefly, and I have. Now we're going to go over, and I've got Simplify open right here, and we're going to go into this slicer. Okay, and you can already see I've got the dark theme going. Again, you can turn this into a light theme if you'd like. I'm going to say this before I even go into this slicer, and I want you guys to really think about this. This is not a free slicer. And I'm going to tell you why I don't like free slicers. I know a lot of guys are fans of Cura and all this other stuff that's out there. Free usually means corners are cut somewhere. Not always, but in the most part, there's always going to be
a lack of funding to do things what I would consider to be right. And when I say right, you want the end user, in my eyes, to have the most available options for them to develop engineering quality parts. Again, I'm using my printer, like many of you, to make money with. Therefore, I'm looking for feature sets that are not going to hold me back. I'm looking for feature sets that are fully functional and also able to be understood out of the box. So Simplify has been on the market for some time. I'm not going to go into a crazy review of Simplify, but I want to just show you the difference in direct comparison between Cloud Print for the method and what's available in Simplify. And again, I'm using the 5.1, the latest revision. Again, you can see in Simplify you have what's known as processes. And again, you can have multiple processes, and this is just to touch base on how powerful this software is. You can have multiple processes on a single print that allows you to print in different layer thicknesses, in different temperatures, for different outcomes, which is absolutely amazing. If you want to print just a single layer of PVA with your secondary extruder, you can do that. And to me, that's true engineering grade, where certain components may require a softer substrate in terms of bonding strength, so it can be removed from supports so that you actually don't damage the component you're working with. This is very, very powerful, and this software allows that. That's just one of its features. Let's open up the processes, and you can already see how different this software looks. Again, we've got experimental extruder loaded, extruder 2A, which is my PVA extruder. I'm going to be honest with you guys, since I've been using this software, I have not even used my roll of PVA. I bought another roll of PVA. I haven't even touched it. I haven't had to. I've been able to print solely on the build plate without touching my PVA, and it's dramatically reduced the overall cost of printing. So much so, it paid for this software. Now, many of you want to know how much Simplify is. Very simple. It's $200. Once again, I'm not being endorsed by them. I'm going to tell you right now, whatever you have to pay in conjunction with a $6,000 printer to make it right, $200 to me is a very, very, very small amount of money to give you what this software does. And I'm telling you that. On top of, they offer a, I believe it's 2-week trial where the software is completely free if you don't like it in 2 weeks. And I've never seen that before in production software. That's very rare that you get the full unrestricted version of the software to test and see if you like it before purchasing it. At least you can do a print and check out what I'm saying. That being said, you can see again all of the settings, and some of the settings we really like, and I know many of you are going to like, is we have coasting distances, and again this software does explain with small definitions on what each feature does. How far away from the end of the loop to stop extruding and begin coasting. Wipe nozzle. Wiping distance. How far to continue moving and wiping at the top of a completed loop. Now these are just some for dealing with ooze, your retraction speeds, your extra restart distance. You can see how just systematically this is all set up. It's just very easy to understand. You can see tool 0, and then we have tool 1 through 5. In your case, if you're using just the experimental extruder, whatever extruder you're using, typically it'll be tool 0. I'm just touching base on these. Layer. Look at the feature sets. Okay, you can already see that the stock layer height, and I was absolutely amazed by this, in Cloud Print software is 0.2 millimeter. I was able to run 0.1 millimeter, which is the stock layer height that just loading in Simplify, and the layers are absolutely amazing. So much so that you can't even see the lines when you're using nylon carbon fiber. They're basically gone.
Okay. Let's see how this came out, and you can see the scarring is all on the inside, of course, and you can see your layers, because I got asked numerous times about my first layer, and you can see the quality of this is ridiculous compared to what you typically get with the cloud software that comes bundled with Makerbot. Also, I want you to pay very close attention to how solid all of the fill is, and this is just an electronics enclosure. But you can see here how clean this is. I did 0.1 millimeter, so you can see exactly what you have, and the print is truly amazing. All I did was use glue stick on the actual build plate, and again, no more purge tower. So many of you guys that are serious about printing keep that in mind, that that purge tower, yeah, you can turn it off through cloud software for Makerbot, but you're never going to get the quality, I found anyways, after at least 100 hours of printing trying to work with that software, that you get with Simplify. And I'm only using a one-layer skirt around it, and you can see just what's left here. I mean, that's just one strand. There's all the glue stick, and I have a different method that I use for actually doing the prints, but again, seeing this up close, and I'm hoping you can see the detail in this because it is truly amazing. You can't even see the lines. I mean, it's that clean.
I mean, it looks more like a molded part. Again, you have total control, total definitions of each feature with total control on first layer settings, which is amazing to give you so much control. When I use nylon carbon fiber, I find first layer speed at 20% is amazing. When you're dealing with PETG filament, I drop it down to 10%. And I find it's absolutely amazing. I cannot get PETG filament. I was using Jable, which is from a recommended filament that was discontinued from Makerbot, and it was absolutely horrific. I dropped down the first layer speed when using this software down to 10%. I also adjusted the Z-axis height slightly, and it made a tremendous difference, and I was able to print with it, which blew my mind. So again, and also doing so without a purge tower. Again, you can enable adaptive layer heights. Adaptive layer heights, once again, allows you, and that was just the feature I was discussing, if you decide to create a print with, at certain different areas of the print, use a different layer height for that area, you can do that. So again, you've got a lot of different settings, and again, just to cover the settings that this allows you to do is absolutely amazing. And here is under additions where I think most of you are going to applaud, because I know I did. First of all, you've got a skirt and a brim which you can set up. You can use a raft or not use a raft. You also have a prime pillar, and you also have an ooze shield, which with this printer I think should be mandatory, especially at the price point it is. And this ooze shield actually works. Everything here works, and you do have a lot of fine-tune ability. Again, looking at these features, you start adding up, you know, what's it worth again? You know, you're looking at a $200 fire and forget investment. It's pretty amazing what you've got. And again, I'm only at additions. Infill. Again, I'm using infill extruders experimental. You can choose your infill pattern. Again, most of this stuff is very, very simple. Now, here's a feature on 5.1 which is awesome. If you're looking for a finished component to come out with amazing detail, iron top layers. It'll smooth top layers using an additional ironing pass once it prints. So it gives you basically no filament extruding. It just uses the hot end of the tip to go over your print on a layer that it's completed. It is amazing with this printer. I'm just telling you that right now. It does take more time, but again, if you're selling high-end parts, it really doesn't matter. External infill pattern, you can change everything from internal to external. Top layers, again, it's a broad range that you're working with. Supports. Again, you do have supports where the software will recommend what is required to be supported, and you can adjust everything, and I mean literally everything. Temperature. This is really awesome. Enable temperature controller, stabilize temperature controller at beginning of print. That's an option you can do. I find with my filament, as far as my nylon carbon fiber, and the reason I say my filament, I'm using Makerbot's filament, but every roll is going to be slightly different. There's no way in hell it's going to be produced with extreme accuracy that every roll's temperature is dead nuts on. It just doesn't typically happen. So with this particular roll, I've dialed in at 252 degrees Celsius, and I can tell you right now, the printer you're going to find, at least mine, is always off by 5 degrees Celsius, give or take. And that's when it's at the actual temperature, and you will see that using your software. And again, Simplify will show that as well. I find 252 usually prints at a real temperature of 248, and it bonds all of my layers together virtually perfectly. You've got a cool down temperature, required idle time, reheat time. These are settings, again, in the cloud print you're never going to find. They don't exist, and again, it really makes the print that much better. You can also set different layers temperature if you decide to do that, which again, for utmost in control, guys, that is just amazing. So for layer 1, if you don't put a layer after this, if I was to put another layer, it would adjust that layer to a certain temperature. But if you don't put anything, it'll just print from layer 1 and go on and so forth at that set temperature. So again, for customization for certain components, it's endless. And I mean, thinking about that is truly endless. You can then select your secondary extruder. Again, I don't even have mine active. That shows you how much I've been using it since changing this software. It's been amazing. The heated chamber, you can set your heated chamber temperature. You can also set your heated chamber temperature, again, based on each layer, which is truly amazing. I mean, that allows you ultimate control to give you, ultimate control over any type of warping that may happen. This is the way software, in my eyes, should have been done for, once again, the printer of this value. So again, cooling speed for your fan, you can do that. Again, adjust it to every layer if you decide to. I don't mess with these settings. Speeds, I've done very little manipulation with the speed setting. As a matter of fact, the XY travel speed, I'm printing at 3,700 millimeters a minute. And I'm going to show you her print so you guys can see exactly what I'm seeing, because I couldn't believe it. I was like, you know what? When I first dealt with the cloud print software, like many of you, I had to turn the print speed down ridiculously slow. And I'm like, you know what? This doesn't make any sense. Why do I have to do that? And then, you're thinking, well, it's an engineering printer, and, maybe it's because you want to have, you want the parts to come out not just right, but they've got to come out to a resellable condition. In this particular instance, when I first changed over to Simplify, I could not believe my eyes of what I was seeing, and I did not touch any setting. You can print with the stock settings in Simplify right out of the box, and it just blew my mind. As long as you do your calibration of your extruders, the assisted leveling, you are going to be golden. But I right now have my travel speed set at 3,700. Z travel speed is at stock speed. None of these percentages have been changed. Again, none of these settings have been changed. I'm going to show you exactly what I have changed. Z-axis, my offset for my Z, which is just adjusting your Z-axis height, I set it to negative 0.01 millimeters, which again, guys, we are talking thousandths of an inch. Made slight difference to the adhesion with the nylon carbon fiber, especially when using a glue stick, because you don't want it to stick so much that you'll separate your first layer. You want your parts to come out right, and believe you me, mine have been coming out like glass. I will show you that. Overall, first layer looks gorgeous, and again, you've got even more features to set up as far as the software itself. These are just general settings. And again, Makerbot Method X, Labs Extruder, these are where you select your extruders. You can select your material. Something else I love about this software is that as an engineer, it does let you put in the cost of the filament, so you can dial in the cost of your components when you're printing them. Again, priceless. I cannot believe they did not put that in Makerbot's Cloud Print, but again, nothing surprises me. Once again, you shouldn't have to mess with anything here except possibly the Z-axis offset. Script, again, you can change if you want to do direct programming yourself. I don't see the requirement to do that. Other. Now this area is interesting too, because again, you've got bridging you can mess with. These are really advanced settings, and again, I have not personally had to mess with any of this, but again, it just shows you the depth of what can be done with using software at this level. I know that Cura is very capable as well, but looking at Simplify and seeing the end results that I've seen is it's just mind-boggling. I mean, it's really changed this printer overall tremendously. Again, you can change your tool change retract distance here too, and you can see most of these settings I have not changed. These are all stock. Advanced. Now I'm going to show you something here that's probably one of the most powerful features of this software. Is under ooze control, all of these settings you can manipulate, but where it really gets interesting is movement behavior. Modify travel movements to avoid open spaces. And you can see I've set mine up at 500 millimeters, and that's the default factor. So basically what that means, it's going to take longer to print. I'm going to tell you that right now. But if you're printing finished products like I am, then you do not want ooze nodules or ooze zits all over the print. In which case, when you set this up and you set the parameter for the detour factor. The larger the detour factor, if the part is smaller than the detour factor, the nozzle is always going to trace itself over the part to move to another area to print. What does that mean? If it's never over an open space, meaning the extruder nozzle never passes over an open space, it doesn't give the extruder time to ooze. So you get basically a perfect part. This is an amazing feature, and again, why it wasn't implemented in Cloud Print, I have no idea. I mean, this is, like I said, this software has taken this printer at the level that it should. And then once again, looking at it, you can see all of the other update files. You can change your profiles, save as new. Right now I've got the auto configure for quality at high. And again, I'm going to go into this software in more depth. This is just what I wanted to show you guys from the beginning. And again, wiping mode, wipe inner and outer perimeters. You can change this. Wipe outer perimeters only, wipe all features. I mean, it is ridiculous. So much so that I think some of it's overkill. I mean, at least in my knowledge and looking at what's required. The minor settings that I've adjusted, once again, movement behavior, I've adjusted that, and I've adjusted this to 500 millimeters. And then coming over here, once again, the temperature, which again, we all adjust. I haven't messed with any additional layer temperatures, although you could. And again, layer height, this has been stock. I have adjusted and played with different layer heights, but you know what? I just love that 0.1 millimeter. It looks amazing. Again, depending upon what you're trying to do, if you're looking at a faster print, by all means, adjust it. You still get super quality. It's just then, of course, lines become more present. Extruder, again, nothing here really. I did put in some settings here slightly. I just adjusted the coasted end to 0.9 millimeters and then wipe nozzle 3.65. Now what's interesting is after printing with nylon carbon fiber, which is my go-to, and also the PETG from Jabil, I had such bad results. Makerbot was really friendly in the sense that they sent me another roll of it because it was just horrendous. The first roll I had, I could not figure it out. I could not understand why this filament would not stick. And then finally, after once again testing this software, making the adjustments, first of all on the first layer, adjusting your first layer print speed. Again, I highly recommend staying at 20% or under, at least for the first time you print, just to see what happens. And you guys can adjust this speed each time just to see where you're at. The whole idea with printing, of course, is reducing the amount of trial and error, because that gets so tedious, and you know, YouTube videos make it look easy, but who wants to spend 10 to 15 hours at a time just going through different print layer speeds? The best thing to do, I found, is adjust this by between 5 to 10% max, and I have not exceeded 20%. I would rather my print go slow on the first layer to get it perfect, and then speeding up. Your bond strength is there, and you will definitely get a nice finished part. Again, extruder, just to make sure everybody's got it, wiping distance 3.65 millimeter I find is really good. Coast at end 0.9 millimeters. Now again, I am using nylon carbon fiber. If you're using PLA or a different filament or something else to be discussed, if you're using filament from another manufacturer because you're using an Extruder Labs from Makerbot, you want to make sure that you take your time with it because they're going to react differently. One thing I will say is Makerbot really does have nice filament. The filament is amazing in quality, at least the ones I've used. The only thing is it all needs to be dried. If you follow the drying cycles, you are going to be set. I cannot say that enough. So now that you've seen the settings here and you've seen what I'm talking about, I want to cover one more area with this software. And this is something I really love, is opening up the machine control panel. And again, you do have Ethernet capability and communication with Simplify. You simply click on connect, and now it's connected to the printer, and you'll see all of our feature sets now are going through. It's sending all the information. You can see now our axis position. You can use the movement grid right here if you decide to. Accessory controls you've got right here. You don't see anything lit up because, again, none of the nozzles are heating up right now, but you can see all the temperatures. You can set this. You can click on disable motors. This is amazing. Sensor data, when you're heated up, you can see that as well. Device files, I have not seen this populate. I'm sure that if you did send a file or start manipulating files, it most likely would. But as far as communication, this is probably the area I stay in the most. When you send a file, you'll see progress line go, and I will show you that in a later video. I just wanted to cover the software in general, but you can see this is a long video just discussing basic features. Again, you can already see that this is way more complex than what you've seen with CloudPrint, and it is truly, truly amazing. And I'm going to show you guys live what a print looks like at the settings I'm using so you can see yourself. Again, I'm not trying to sell you on anything. I just want you guys to know what's out there and understand that, and I've said this before, if you're spending the kind of money you are on a method, you need to understand that the software that's controlling it is actually more important even than the hardware of the method, because if it can't utilize the hardware, meaning the software, you're basically at ground zero. You'll never get the results you want. So again, I hope that this video has been helpful. Stay tuned for me doing active printing with the settings you've seen. Like and subscribe, and of course, let me know in the comments section what experiences you're having. Take care.
Hey guys, it's Vince with Mastering the Method, and today I am doing a video to answer a question that was asked on my channel regarding ooze. I was actually requested to print two of the same components that I have done in a previous video where I printed only one, and do them together using only the secondary extruder to prove that the ooze is gone. Well, you guys can see right here, I'm working on the first layer on the component on the right side, and the left side's already got the first layer down, and you can see I've got just a brim, and it's immaculate. Of course, it's moving really slow right now because we are putting down our first layer, and I highly recommend, if you're using Simplify, use that adjustment to, once again, put your first layer down around 10-15%. You're going to be really happy. Again, printing with PVA, if you're doing just a secondary extruder print, do not exceed 800 millimeters a minute, because if you do, most likely you're going to have issues. And again, this is just something I found out, but overall you can see exactly what's going on here. And what I love about Simplify, when the first layer is done on this side, you'll notice that the way it actually goes and moves the extruder to avoid any open spaces to cross as, again, as short a distance as possible, eliminating any potential ooze. That's something we just don't get with CloudPrint, and of course many of you, like myself, would really appreciate it. I personally feel there's just not enough CloudPrint settings to adjust ooze, and that's what really leaves this printer in the dust, and so to speak, as far as getting finished prints that look the way they should. Again, trying to get in as close as possible. You can see exactly what's going on there. Let me see if I can refocus. There we go.
Okay guys, I'm in Simplify, and I wanted just to show you something and make you all think about something, because I was thinking about this. And looking at this, the way that you can do it in being able to print with only one extruder at a time on a dual extruder machine makes your ability to set it up much, much faster. Let me explain. When you print typically with CloudPrint and you're forced to print with both extruders at once, most end users find that they're always tackling both extruders in terms of making corrections at once, and they have to document all the variables with each extruder at that point, and hopefully can record them in a way that they can, formulate a possible solution to get the outcome that they're looking for with their prints. In the ability in Simplify to print with only one extruder, either the model or extruder 2 or both for that matter, if you're attempting to set up an individual extruder, it's much easier to do one at a time than it is to print with both of them together. And again, just coming in here, you can see I can select extruder 2, and when I do that, I can come in here and select all of the settings that I want to adjust prior to printing with just this extruder. Now think about this. For a novice, or for someone that wants to hit the ground running as fast as possible, had I known that I could do this with Simplify before it was even released to support the method myself, I would have been able to set up one extruder, preferably the support extruder first, because it's the more difficult of the two, and then after I set that up, and I feel comfortable with that printing by itself, I can then add the additional extruder to do combination model prints. Think about what I just said, and I think you'll see my point. And again, coming in here to select one, two, or both extruders at once, I really think this is the key to really understanding how working with a dual extrusion printer is, because I know there's many people out there that say there's a lot of printers that are better than the Method, and I want you to think about something that regardless of what printer you have, if it has multiple extruders, you are as an end user going to eventually have to set up both extruders to cooperate and perform well together. Whereas single extruder printers, they don't worry about that. They just print one time and that's it. We have two extruders, that means twice the problems. So again, I hope that makes sense to you.
Right now, just finishing up that ring. Okay, now we're knocking out that first layer. Okay, we are getting ready to hop over to the next component, and I wanted to show you the pattern. It uses a very short travel distance to do it. You can see we're going to go around the brim. Now we're going to do our hop. Nice and clean. Now we go the other direction. Okay, it's going to get ready, and we should be going to the secondary component as soon as it hits this layer. Boom. And you can see how it tracked to the middle of the component on the right, and once it got to the middle, it jumped over. And the reason it did that is that's the shortest distance. So again, we're trying to mitigate any potential ooze, even with all your retraction settings, your ooze shields, as many options as possible. And again, I think that's really what we all want and need. Going around, just leveling it out. Okay, we are now at 36%, and you can see, hoping you guys can see it, we have got about the size of a pinhead amount of ooze between, actually just going between the two prints. You can see it right there. See if I can come on this side. There we go. And that's it. That's all we got. And I'm 99% certain that by the time this is done printing, that'll probably either fall off or be able to be snipped right off. And keep in mind, I'm not using an ooze shield. I'm not using even a purge pillar. I'm just using the brim option. So it's pretty amazing to see such a difference in the filament when it's dried properly. And again, guys, I can't emphasize that enough. When the filament is dry, it really is amazing to work with. Again, I even have the one of the actual components that I've printed, and these are one of the first ones. And this piece looks just absolutely amazing. See if I can get its focus. There we go. Okay, we are at 67%, and I think you guys can see those tiny little zits That's about the extent of the ooze I'm getting, and I believe I'm going to correct that with some coasting. And just so everyone out there understands what coasting is in Simplify, it allows you to basically adjust the distance in which the extruder turns itself off so that any purge will come out over that distance. But it can also leave bald spots in your print, so you want to adjust it very carefully. Very, very clean prints. We'll see what we got. Okay guys, we have the finished components, and I'm showing you just as it's complete. As a matter of fact, Joanna can focus in there and show them the nozzle. Once again, it's immaculate. Matter of fact, here we go again. You can see right there with the dental mirror, the nozzle looks perfect. Let's take this out. Again, we lift from the top and just up straight. And of course, we have our brim. You can see that is the extent of our ooze right there. And I'm going to take these off now. 1, 2. And we can see right there some ooze, and that is about it. Let's see how quick this is. I'm just gonna clip that. Done. This side's actually got a little more. You can still see we got some right here. That's about it. Once again, easy to clip. And we have a perfect piece. Let me just come over here, one more. Done. And that's perfect. And there you go, guys. I mean, that's how simple. We got one in here too. Yeah, it looks like we have a little overflow. Innards. There we go. Most of these just come right off, but either way, there we go. And you can see the brim and how clean this is. We do have some stringing coming over from the brim. So again, that has more to do with the bonding on this layer for the brim, and that's why we got that string. I'll go wider, and I've said this in previous videos. Keep your brim as wide as possible, just in case that happens, because you don't want this to hit your print if you don't have to. But other than that, considering these are out of PVA, it's pretty amazing. Looks like we have another little crumb in there. There we go. These are perfect. Here we go. So again, guys, yeah, looks like a little string. This is what we can achieve when we dry our filament, and the only thing I'm going to adjust is a little bit of coasting. The coasting settings that are within Simplify right now, if you're using it, they work fine. I'm just going to up them slightly. We don't want to have any bald spots, but we certainly want to make sure that we stop the extrusion of the extruder in terms of us actually filling that gap without actually having overhang, because we don't want to create a bald spot, nor do we want to have too much filament where you're getting the ooze. So we'll adjust that slightly, but again, for 98% of end users, compared to what I've seen, this looks amazing. I think you'd agree. Thank you guys for your support, and I'm going to adjust the coasting settings. Post in the comments what you would do in terms of correcting that slight ooze, if anything, because I'd love to hear your ideas. Again, thank you all for support. Give me a thumbs up if you like the video. It really helps the channel. Take care.